Hello everyone, welcome back to another SLHL IB chemistry video. Today we will be looking at measuring enthalpy changes under the reactivity topic. So let's get to defining what enthalpy is. So enthalpy is simply a measure of energy within a thermodynamic system. So this way we now better understand what this is because we will be using this word a lot today. So one of the key things that we should understand when it comes to measuring enthalpy is the difference between heat and temperature. So heat refers to the energy exchanged due to a change in temperature between two substances. Now, differently, temperature is simply a measurement of the average kinetic energy of particles in an object. So to calculate a change in enthalpy, getting a bit ahead of ourselves, but it comes on nicely with this, you will have to add the change in the product enthalpy to that of the reactants. So to determine if a reaction is endothermic or exothermic, we will have to look at the overall change in enthalpy. Let's just take a nice simple example before we get into Hess cycles, when this will make a bit more sense. So let's say that we are trying to make ourselves some fertilizer. So right here we've got nitrogen and hydrogen to make ammonia, and we are forming bonds between the nitrogen atoms and the hydrogen atoms. Now, since we are forming bonds, if you go into your data booklet, you will also find the data values for bond enthalpies. And for a nitrogen to hydrogen bond, your bond enthalpy will be of 390. And since we are making 6 of these bonds, 2 times 3, that will give us about 2,340. Now, since we are making bonds and not breaking them, we know that this reaction is endothermic because the breaking of bonds is what releases energy. The release of energy will increase the temperature, and therefore energy is exiting the system, so exit exothermic, and formation of bonds endothermic. Energy is going into the system. Now, in terms of the relative stability of products, this has to do with their profile level diagrams. So let's just draw some out. So, oh, that's not a very nice, oh. All right, that's gonna have to work. So let's draw a nice little energy profile diagram over here. So here on the left, we just have energy. So here actually let's make that delta H. So here we can see an increase in delta H. So there is energy coming into the system as your enthalpy at the end is higher than that in the beginning, suggesting that there is a, as we said, positive increase in this value, suggesting or showing us that this is the energy profile level diagram of an endothermic reaction, such as our ammonia over here. Now for an exothermic reaction, what we will see is something that looks a little bit more like this. We see an overall change, a dip in enthalpy, meaning that it is negative and energy is exiting the system. Imagine this space under here represents the energy in our system. Now, as we can see here, let's pick a different color. There you go. So over here to our left on our endothermic diagram, we see a very, very large jump, whereas on your exothermic one, you see a very little one. These jumps represent the activation energy, or in other words, the energy that it takes to kickstart a reaction. So to our left, we see a very high activation energy, meaning that this endothermic reaction is fairly thermodynamically stable. This means that it takes a lot of energy to start and is not as likely to start from a very small little input of energy in comparison to our exothermic one over here, which only requires a little bit of energy, say a spark or a really small flame from a match to kickstart this reaction. And finally, let's take a look at some of the equations that you will need to know and to work for this topic. Let's get back to our black pen. So Q equals M cat. So here, Q represents your energy in joules, M stands for mass, and delta T is simply the change in temperature in Celsius or in Kelvin, because it's the same thing. So to calculate this, you stick your values in and then you get a nice little value out. Oh, and correction, C is your specific heat capacity, 4.18, and this should be given to you in your data booklet. This is joules per kJ. Your mass will be in grams, and temperature, as we said, Celsius or Kelvin. Since it's only a change, it doesn't really matter. This equation will often come alongside this one over here, which is change in enthalpy, is equal to Q over N, negative Q over N. Thank you for watching and hope that this was helpful.